Hello viewers, the topic of today's discussion is relational algebra. The objectives of today's discussion are to understand the concept of relational algebra, to explain traditional set operations of relational algebra, and to prepare relational algebra queries for a given condition using traditional set operations. Let us first understand the definition of relational algebra. Relational algebra is a method of specifying a sequence of operations to be performed on a database in order to compute a desired result. For example, if we are given a query and we want to find out the desired information from the underlying database, then relational algebra provides us with a set of operations which can be performed on the database. It consists of a set of operations that takes one or two relations as input and produce a new relation as output. There are two types of operations in relational algebra, that is traditional set operations and special relational operations. Traditional set operations are basically derived from the mathematical set operations, for example difference or set intersection, whereas the special relational operations are those which have been specially designed for relational algebra. Traditional set operations. Traditional set operations are of two types: unary operations and binary operations. Unary operations are those that operate only on one relation, whereas the binary operations are those that operate on pairs of relations, that is, they take more than one relation as input. Select operation. Select operation is an operation which belongs to the category of unary operations. It selects those rows that satisfy a given condition. It is usually depicted by sigma or simply by writing the word select. The relation to be operated upon is usually written in parentheses following the word select or sigma. The basic purpose of select operation is to derive certain tuples which satisfy a given condition. Let us now consider that we have a relation named EMP which contains the information about the employees of an organization. Let this information be their employee number, employee name, and salary. Let there be four tuples with this information as depicted here. Then, if we are given a query to find all the tuples in this relation in which the salary is greater than or equal to 2000, then we can use the select operation in the following manner. That is, we will write the word select followed by the condition that salary should be greater than equal to 2000, and we will write the name of the relation EMP in parenthesis. So here selection will be performed on the relation EMP with the condition that salary is greater than equal to 2000. This will give us this result. The result will contain the tuples which correspond to the condition salary greater than equal to 2000. As we know that in the EMP relation there are only two employees, John and Sham, who have the salary greater than equal to 2000. Therefore, the result contains only two tuples corresponding to them. The condition which is used in a relational algebra expression may include comparisons using equal to, not equal to, less than equal to, greater than and greater than equal to. Further, several conditions can be combined together into a larger condition using the connectives and or. For example, if you are given a query to find those tuples in the EMP relation with employee number greater than 120 and salary greater than 1800, then the relational algebra expression will be: select EMP number greater than 120 and salary greater than 1800 followed by the name of the relation, that is EMP, in parenthesis. Basically, we are combining two conditions, that is EMP NO greater than 120 and salary greater than 1800 using the connective AND. Project operation. Project operation is another operation in the category of unary operation. This operation allows us to get a relation which is the subset of the original relation. For example, if we are interested only in knowing the employee number and employee name of all the employees and not in their salary, then we can use the project operation. That is, we can take a subset of the employee relation. It is specified by writing the word project followed by the attribute names as subscript of the word project, and this is followed by the name of the relation to be operated upon in a pair of parentheses. For listing all the employee numbers and names from the relation employee, the expression will be project EMP NO, EMP name followed by the name of the relation EMP in parenthesis. So here the projection will be performed on the relation EMP and we will get only the employee number and employee name of all the employees in this table. Now let us consider that we are given a query to find the employee names whose salary is between 1800 and 1900. Now here we know that we are interested only in the employee names. So we will have to perform projection. We will write the expression as project employee name bracket select 1800 less than equal to salary less than equal to 1900 followed by the name of the relation EMP in parenthesis. Now here we have a nested relational algebraic expression, that is, first the select operation will be performed and all the attributes, that is EMP NO, EMP name and salary will be returned for the employees whose salary is between 1800 and 1900. Later on this relation the projection will be performed and we will derive only the employee name. Binary operations. For binary operations, there is a condition that the two relations must be union compatible. We will see what is the definition of union compatible. Two relations are union compatible if they have same number of attributes and one-to-one correspondence between the attributes with the corresponding attributes defined over the same domain. So very important concept is that the domain of the corresponding attributes should also be same. Then only the binary operations can be performed on the input relations. Union operation. This is a operation of the type binary. It is a binary operation which operates upon union compatible relations and results in a relation by adding together the tuples from each of the input relations. That is, it unites the two relations to produce a new relation. Only thing is that to perform union operation, both the relations should be union compatible. Let us say that we are given a relation department which contains two attributes, employee number and department name. It depicts that a particular employee is in a particular department. For example, the employee number 121 belongs to the department computer and so on. Now, let us assume that we are given a query to find the employee number of all the employees who have either their salary greater than 2000 or belong to computer science department. That is, we want to find out the people who have either their salary greater than 2000 or they belong to computer science department. To answer this query, we will create a sub-expression. That is, we will create a part of the relational algebra expression first. That is, we will try to find out the employees with salary greater than 2000 as follows. That is, we will write an expression like this: project employee number bracket select salary greater than 2000 followed by the name of the relation in parentheses. This expression will give us the employee numbers of all the employees whose salary is greater than 2000. We will also create another sub-expression to find out the employees which belong to computer science department as follows. That is, project employee number bracket select department name is equal to computer followed by the name of the relation, that is department, in parentheses. This particular relational algebra expression will give us the name of the employees who are in the computer science department. And finally, our query's answer will be sub-expression 1 united with sub-expression 2 using the union operation. This will precisely give us the set of employee numbers who have their salary greater than 2000 or belong to computer science department. Set difference operation. This operation also belongs to the category of binary operations. This operation is denoted by minus sign and it allows us to find the tuples that are in one relation but are not in the other relation. The expression R minus S results in a relation containing those tuples which are in R but not in S. For this operation also, one must ensure that set differences are taken between compatible relations. Now, let us assume that we are given a query to find the employees who have salary greater than 2000 but do not belong to computer science department. It looks like a very complicated query, but it can be easily solved using the set difference operation. For this, the relational algebra expression will be project employee number bracket select salary greater than 2000 followed by the parenthesis containing the name of the relation, that is EMP. The another expression is project EMPNO bracket select department name is equal to computer performed on department. Now we use the set difference operation in between these two set of relational algebra expressions, and the resulting expression will give us the set of employee numbers who have their salary greater than 2000 but who do not belong to computer science department. Thus, this problem can be easily solved using the set difference operation. Cartesian product operation. This operation is denoted by a cross. It allows us to combine information from any two relations. The Cartesian product of relations R1 and R2 is R1 cross R2. Thus, the Cartesian product of the two relations EMP and department will be another relation R denoted by R is equal to EMP cross department. The relational schema for R will be EMP dot EMP_NO, EMP dot salary, EMP dot EMP name, department dot EMP_NO and department dot department name. Dot operator is used to distinguish between the employee number of EMP and department relations. This is because we have got employee number as a common attribute in both the relations EMP as well as department. Now, as we know that dot operator is used to distinguish between the common attributes, therefore we need not use this dot operator with the attributes which are unique in a relation. Therefore, the same relational schema can be written as EMP dot EMP_NO, EMP name, salary, department dot EMP_NO and department name. So basically we can use the dot operator only before the common attributes in the relations. The relational schema R will consist of each possible pair of tuples, one from EMP relation and one from the department relation. So basically there will be a large relation, that is R will be a large relation. Number of tuples in the resultant relation will be number of tuples in EMP multiplied by the number of tuples in department. Thus, we will have one tuple from one relation related with every other tuple in the other relation. Thus, in this unit, we have learned what is relational algebra, what are the different traditional set operations which are there in relational algebra. We have learned selection, projection, set difference, Cartesian product and union operations. In the next unit, we will elaborate on Cartesian product. We will see how it is used to formulate the relational algebra queries. Till then, goodbye.